Hi there! In the last video I made an Arduino-based controller which allows the Dobot Magician robot arm to be used as an automated pick-and-play system in combination with the Pixie 2 Vision module. Although it worked well, it had a very Spartan human interface based on an LCD shield. The LCD shields are actually very nice for simple projects and prototyping, but when your project requires an extensive menu system, the huge amount of button presses required to get you to the setting you're looking for can be a bit annoying. The solution to this problem was the fitted touchscreen. In this video I will go through the steps to make the new controller with the touchscreen, from generating a menu in the Nextion editor, creating the Arduino code, making a dedicated enclosure, assembly, and finally a demonstration of the new controller in action. So let's dive in. In my search for an Arduino compatible touchscreen, I came across the Nextion module. The Nextion touchscreens are available in several sizes, ranging from 2.4 to 10 inches, and there are several product lines with different feature levels. For this project I opted for the basic version with a screen size of 3.5 inches, which cost around 40 euros. The Nextion display is connected to one of the serial ports on the Arduino for two-way communication. I prefer this approach over a shield module, since you are more flexible in designing an enclosure and leaving all the other Arduino pins accessible for other uses. There's an Arduino library available, which makes it quite easy to read the user input data from the display and also to write back the values to the screen or to change button states. You might think that a graphical interface takes a lot of resources from the Arduino, but this is not the case. The graphical interface is fully driven by the onboard controller on the Nextion display itself. The only thing the Arduino has to take care of is a serial communication. Let's start with making a menu system for the Nextion display. You can download the Nextion editor and the Arduino library from the Nextion website. I'll put a link in the description below. The Nextion editor is free software, which allows you to build the graphical interface for your project, including buttons, images, and built-in code where needed. I will go through the design of the interface at a fairly high level to keep this video short, but if you need more information on how to use the Nextion editor, I would recommend the InterlinkKnight YouTube channel, which contains several videos on how to use the editor and the touchscreen. Link to this channel in the description below. After starting a project where you indicate the type of display and the orientation, your project is opened in the main editor. On the left side, components like buttons and text fields can be added to the active screen. The picture window on the lower left can be used to import pictures for use in the background or to indicate the current state of a button. In this project, I use this to place an open and close icon on the gripper button. The output window shows messages from the editor, for example, when compiling your code. This will allow you to debug your code. In the event window, you can add actions or your own code for any element you place on the screen, for example a button. The types of actions are dependent on the type of object you have selected. The page window on the right allows you to add different pages to your project to keep things organized. In the attribute window, you can change properties of the selected components like size, color, text, etc. In this project, the regular buttons are used for actions like moving the robot arm or for changing to a different menu page. For example, let's look at the plus button on the jog menu page. This button sends its ID to the Arduino via the serial port, so the Arduino knows the button was pressed and can initiate the desired action, in this case to move the robot arm. For this button, which has object name B7, I place a check mark in the Touch Release Event tab. When the button is pressed and released, the Nextion sends a touch release event to the Arduino for button B7. Some other buttons on this page are dual state buttons, for which the name starts with BT instead of B. For example, the X button for the X-axis selection. For this button, I wanted the Arduino to know if it was pressed, so also in this case I place a check mark in the send component ID. However, I also wanted to deselect all other axes when this button is pressed, since you can only jog one axis at a time. This is achieved by the code under the Touch Press Event tab. It uses an if statement that depresses all other axes buttons when this button is pressed. Note that the Nextion editor can be quite finicky about the syntax, for example if there's a space where it does not expect it, which can be quite confusing for the user. So if you get any errors from the compiler, look at some other code that does work and try to reformat your code in the same way. For each page, I also used some code for the pre-initialize event to let the Arduino know which page is selected. This is done with the printH command. This allows the Arduino, for example, to update any text fields in the current page when it sees that a new page is loaded. In this case, it is used to populate the yellow coordinate text fields when the page is first loaded. For most buttons, I simply used colors to indicate their state. Blue is depressed and green is pressed. This behavior can be changed with the BCO and BCO2 parameters. However, for the vacuum button, I wanted to use an icon to indicate the state of the vacuum cup or gripper. This is either blue with an open gripper icon or green with a closed gripper icon. To achieve this, I made a bitmap in Inkscape with the same aspect ratio as the screen, which is 3:2. The size is not important at this stage, as long as the ratio between the width and height is 3:2. I placed this on top of a screenshot that I made from the menu page in the Nextion editor. If you align the screenshot with the rectangle and change the opacity of the rectangle, you can see the position of the button for which you want to design an icon. You can then draw the icon, change the opacity back to 100% and export only the rectangle with the icon as a bitmap. This can be done by pressing Ctrl-Shift-E. Change the image size to 480 by 320 and press Export As. Now do the same thing for the open state of the button, so we have two images, one with the blue open icon and one with a green closed icon. Back in the Nextion editor, import both images by pressing Add in the picture window. Each picture will get an ID number assigned by the editor, in this case 0 and 1. Next, you can select the correct picture for the button by entering the ID number in the Pick and Pick2 fields. This project contains 6 pages to display the various menus. There are 4 main menus. The jog menu, which is used to manually jog the robot arm to any position and to operate the gripper or vacuum cup. The auto menu, which is used to start the automatic pick and place cycle using the input from the Pixie 2 camera. The settings menu, where you can go to several predefined positions or change the end effector type. It also provides access to submenus for setting speed, acceleration and delay times, as well as a submenu with a QR code which links back to my website. The last menu is called Cal, which stands for calibration. This is used to calibrate the vision system. This is needed to translate the coordinates between the camera and the robot arm. In my previous video, I covered this in more detail. Also in this menu, you can set the locations of the bins where the various parts should be dropped. Changing between menu pages is done by assigning a page command to each button under the touch release event. This lets the Nextion know that it needs to go to a specific page. The same method is used for entering submenus and returning to the main menu by means of the back button. Just a couple of notes on the slider components I used in the speed menu. For each slider, I sent a touch release event for both the touch press event as well as for the touch move event. This allows the Arduino to update the number field above the slider in real time when the user is touching or moving the slider. In the editor, the behavior of the menu system can be evaluated before uploading it to the display by pressing Debug. This will bring up a simulator where you can press buttons to see if they respond as intended. You can now actually switch between pages using the menu buttons. Also, the simulator generates output that the actual display would send out through the serial port. This is very useful for debugging purposes. Of course, any changes made by the Arduino to the state of the display components is not captured here. But you can simulate this by entering commands the Arduino would send in the instruction input area. When it is time to test the menu on the actual Nextion display, the code can be uploaded via the serial connection or through a micro SD card. Only the SD card option is covered in this video. Press compile and verify if there are no error messages. Select TFT file output under the file menu. This writes a TFT file to the microSD card plugged into your PC. The single file is all that is required to update the Nextion with your project. Disconnect the Nextion from power and the serial connection. Place the SD card in the Nextion and turn the display back on by connecting it to 5V power. Just to be safe, do not connect the serial wires yet. Wait for the update process to complete. Unplug the display again, remove the SD card, and now connect both the power connections and the wire for the serial connection. I also reset the Arduino after reconnecting the Nextion display, just to make sure that we have a clean start. Now let's have a look at the Arduino program. Before you can use the Nextion with the Arduino, you need to download the library. Link in the description below. In order to assign the Nextion display to the desired serial port, open the file called nextconfig.h under the Arduino libraries folder. This is needed to assign the Nextion display to the serial 2 port for this project, which are pins 16 and 17 on the Arduino. If you don't do this, the Nextion will not be able to function properly. Within the file, look for the line called #define next serial. This should be set to serial 2. The Arduino Mega serial ports used for this project are as follows. Serial 0, or just called serial here, is used for debugging messages through the serial monitor. Serial 1 is used for communication with the Dobot Magician, which uses pins 18 and 19 on the Arduino. Serial 2 is used for communication with the Nextion. This uses pins 16 and 17. Here is a wiring schematic for this project. I think it is best to start with a very simple program as an example to show how the Arduino code should be created to work with the Nextion display. In this example, the onboard LED of the Arduino is turned on or off by pressing buttons on the Nextion display. At the start of your program, the Nextion display is included. Each screen object used in the Arduino program has to be declared. The statement includes the page number, object ID number, and object name. Each object monitored by the Arduino shall also be included in a touch event list. Furthermore, each object has its own function, which is called when a button is pressed. Here you can place the code that you would like to run if a specific button is pressed on the display. The various components are then linked to the functions by means of an attach pop command. This lets the Arduino know which function should be called for each button. Finally, the void loop function contains the next loop command, which will read the serial port each cycle and relay the commands to the Arduino. The program for the Dobot controller contains the same type of commands as mentioned in the example. Since there are quite a few buttons and other components on the display, there's a lot more code involved here, but for each item the approach is exactly the same. I'm not showing all of the code here. If you'd like to see or use the code, it can be downloaded from Github, which is of course also linked below. I designed a case for this project, which holds both the Arduino Mega and the Nextion display. The case has a form follows function design. The intention here was to make a practical case that can be used for multiple projects. There's enough room to place DuPont connectors in the Arduino headers underneath the lid. On the bottom, several standoffs are available for mounting the Arduino Mega. The standoffs are meant for M3 screws. The holes do not have a thread, but instead the holes are undersized, allowing the M3 screws to basically act as self-tapping screws. This creates a very strong fixation, but it does not lend itself to frequent tightening and untightening. This would quickly wear out the threads. The same principle is used for the mounting holes of the Nextion display in the lid. The only place where I use threaded inserts are for mounting the lid onto the case, since you might frequently take the lid off when working on a project. The threaded inserts are the cheap kind you can find on AliExpress, and not a good design for using a 3D printed parts in my opinion. But these are the only ones I had available. The inserts are pressed into the lid by using a soldering iron. When using a standard soldering tip, you have the chance of pulling the insert back out, since it's easy to get stuck on the tip. A flat piece of metal can be used to prevent this and leave a nice flat surface at the same time. As you can see, the result is not very pretty, but it does the job. Make sure not to over-tighten the screws with this type of insert, since you have a risk of pulling it out. In the previous video, I made a flat cable for the Pixie module with flat cable connectors on both ends. However, to connect the Dobot to the Arduino, I also needed a flat cable with 2 pond connectors on one end. There are other options, of course, but this gave me the opportunity to practice crimping the pond connectors, which turned out to be quite simple. The connectors should be crimped with the smallest cavity, but I start off with a larger cavity in which the open connector fits. You can pull the connector until the wings of the connector bottom out in the cavity. Then you can close the crimp tool until the connector is fixed, but still able to accept the wire. Place the wire into the connector and fully close the crimp tool. After this step, you can place the connector in the smallest cavity and close the tool again. The connector can now be inserted into the plastic sleeve. I typically check the wires with a multimeter to see if the connection was made properly. There are a couple of wire clamps which can be used for cable management for both the jumper wires and the flat cables. On the left side of the case there is a wire port, which is open at the top, so you can route wires to the outside of the case even when they are already connected. A small strip can be used to keep the wires in place. When the components and wires are in place, the lid is placed on top of the case and tightened from the back with M3 screws. So let's go through the menu of the new controller. The jog menu has buttons to control all axes of the robot arm and a button to operate the end effector, in this case a vacuum cup. After selecting an axis, you can select the jog increment and move the axis in a positive or negative direction. The current positions are displayed in the yellow text fields and updated each time the arm moves. The auto menu has just two buttons, one to start the automatic cycle and one to stop the cycle. Also, it has X and Y fields to display the location of the found part. The settings menu has buttons to save or move the camera position, start position and Z down position. The buttons are color-coded. The blue ones execute a command and the orange buttons are saving a setting to the EEPROM. The radio buttons can be used to select the type of end effector. Under the submenu called Speed, there are several sliders. The first slider controls the motion speed of the arm. The second slider controls the acceleration, so how long it takes for the arm to reach the program speed. The delay time slider determines how long the program waits before sending another command to the robot arm. Using a delay timer is not the best option, but I have not been able to get the position feedback working yet. A very helpful member of the Dobot forum provided me with modified libraries for this purpose, but I was not able to fully understand how they worked, so I decided to stick with the suboptimal code that I had and was able to integrate that into my project. The settings in this menu can either be accepted for single use by pressing the back button or saved to the EEPROM by pressing the orange button. There is also an About menu which contains a QR code leading to my website, which would basically serve as an online user manual for the controller. Adding a QR code is very easy in the Nextion software. You just place it on the screen and type in a hyperlink. Next up is the calibration screen. This contains buttons for moving to the various positions or for saving them in the EEPROM. The large Start button starts the calibration routine where the camera registers the location of the calibration dots. After this is done, the user should manually go to each of the calibration dots with the end effector and store its position to complete the calibration procedure by pressing the Save button in the calibration menu. In my previous video, I go into more detail on the basics of the calibration procedure, so also watch that video if you need more information on this. So now let's have a look at the full automatic cycle while enjoying some royalty-free music. Please give me your feedback on this video in the comment section or by using the thumbs up or thumbs down button. Thanks for watching.